Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The reaction uses HNO2, nitrous acid, and HNO3, nitric acid acting together on toluene. This combination is known to effect oxidative nitration. In this context, HNO to HNO3 can oxidize the methyl group of toluene to an OH group, side chain oxidation to phenol, while simultaneously introducing a nitro group onto the ring, or alternatively the system acts via electrophilic aromatic nitration followed by oxidation. The net transformation converts toluene, C6H5CH3, into a nitrophenol. Moving on to the next step. The methyl group on toluene is an ortho-para director. When the methyl group is oxidized to OH, also a strong ortho-para director, the nitro group is directed to the para position relative to OH. Para substitution is generally favored over ortho due to steric reasons, giving the major product as 4-nitrophenol. Moving on to the next step. 4-nitrophenol has OH at C1 and number 2 at C4. This corresponds to option C. And for the final step. Option A shows a nitroso, no group, not a nitro, number 2 group HNO3 provides nitro groups, not nitroso. Option B 2-nitrophenol is the ortho product, para is the major product due to lower steric hindrance. Option D 3-nitrophenol would result from a meta-director, neither CH3 nor OH is a meta-director. Therefore, the correct answer is C. Therefore, the correct answer is option C.